Okay, so hello everybody, and Linda, can you advance the slide, please? Okay. One thing, and I'm telling Linda this, I'm telling the students this as well. Linda, I am actually two places at once right now. I am available for escalations as they're proctoring my business calculus course. And hopefully everybody there is good at doing things and won't be a problem. But I might get a phone call, and if so, it'll be fine because you would be in Linda's good hands. Okay, but I am, in a sense, in two places at once. But I'm choosing to be physically with you instead of with them right now because they're being well taken care of by their proctors. Okay, I'm going to just make some comments here. Statistics is behind us. If you've taken the midterm, you will not be tested on statistics again in this class. So that's good and bad. Let me talk about, I think it's good actually. So let's just say we covered everything we were supposed to. And you should feel good about that because I did teach the course I was supposed to. We put a check mark beside everything that was supposed to be covered. Another comment that I would make at this outset is you were assessed gently. And let me talk a little bit about that because as those of you who've checked Blackboard have figured out, is I was really gentle in giving you marks on your low stakes assessment. Everybody, it was awarded 100 points for their low stakes assessment. Now that gives you a bit of a cushion, and that's being very generous, or let me say it a different way, it's being very gentle. And this largesse will continue. And largesse means generosity, I think. Okay, so that's sort of where it is. And now tonight, it's a new beginning in physics. Actually, this began whenever I sent out those, what were they called? Videos or whatever, that content contribution. That started talking a lot about physics in there, and actually those videos I think were excellent. The Powers of 10 video I think is excellent, and we're going to be talking about Powers of 10 a lot because ultrasound deals with very high frequencies but very tiny objects, distances, and stuff like that. Okay, so what about physics? Well, some of my first comments is, and some students ask this, is it harder or easier? I would say it's not harder or easier, it's different. And it feels different. And we'll talk just a little bit about some of the differences tonight, but I really want to do some real work tonight, not just do philosophy. Okay, and I hope that was not a tragedy that I have to deal with. Okay, that's not a tragedy yet. Okay, so that's good. What was I saying? Oh, it is based on math heavily. And I want to tell you guys, some of you are going to either learn some math tonight or review some math that you hadn't touched recently. But that's fine because this is a math course. And this math and physics, I guess I will say, has a lot to do with ultrasound. And I'll probably say more about that. And rest assured, I will teach you a good course. Maybe I should say Linda and I will teach you a good course. Okay, my assessment of year to date. I think you people are working hard and things like that. Haven't graded the midterm yet, and that will have to happen. But midterm grading will happen. And one of the things I do is I send individual emails to each student. So for example, if Linda were a student in this class, I would be sending an email just to Linda. I would say, okay, here's where you are right now in the course. And I may give her some kind of a direction of saying, and gee, if you want to do better, here's what you have to do better to achieve. I don't know. I haven't written those yet. Now, some students are probably saying, well, when will these exactly be graded? Well, the answer to that is on this slide. I don't know when, because my life often changes, but from minute to minute. But I don't know when, but soon. Individual emails, I expect people are going to be in pretty good shape. My only comment here is, and that's the frowny face, there were a number of students who still stumbled in submitting their work. Maybe on the final you'll get that. That's another chance, and maybe we'll have some more low stakes assessments. I think maybe we should. Linda, we're going to conduct a poll in a moment, but do you have anything you want to say to the students at large?
Actually, I'd like to do a quick poll. Based on the study guide that I prepared for you all, do you feel like that was adequate preparation?
Okay, so Linda's making up a poll, and that'll come up soon, so you want to be thinking about that. And again, these things, nobody knows who's saying what, so, weigh in. I mean, feel free to play. I hope you do. Linda, while we're giving them a little bit more, the question, yes, someone asked what the question was. Was the study guide...
So do you feel like the study guide was accurate to the midterm? And if not, then I would like to know what you would have preferred to see on it that would make you feel more prepared for something like the final in the future.
Well, damn it, Linda. Oh, wait, it just happened. Linda, you get an A on this because of the people who have weighed in. It's 11 out of 13. I was going to say you got a B until that last person weighed in because it was 10 out of 12, which would be in the 80s. But this takes you above 90, and good for you. So Linda, you get an A on that. So I mean, people liked it, I guess. My poll was just kind of, are we ready to go and study physics? And that's a yes or no thing too, I guess.
Okay.
Okay, way to go. Ready or not, here we come. Okay, Linda, let's go to the next slide then. Oh, wait, oh,
Okay.
no, I'm sorry. Damn it, and it's not damn it, but I'm throwing this open for question and answers from, the students in the class. If you've got questions, I don't know, raise your hand or shout out or whatever we do. And I think I will cancel this, Linda, that poll. And I'll wait a few beats, not very long. So either everybody's exhausted or, we did a good job covering things. Anyway, there you go. Okay, now we are beginning physics. Okay, so Linda, let's go to the first slide. Okay, this is a big difference between physics and statistics. Units matter even more here. Okay, and we'll talk a lot about units, not tonight, because units aren't especially exciting. And I think we're going to talk about something much more exciting tonight. But this little thing, this space thing, I'm going to read this to you. This is in your book, but I'm going to read it to you anyway. In 1998, the Mars Climate Orbiter was sent by NASA to orbit Mars at an altitude above their atmosphere. Instead, it entered the atmosphere and burned up. The key error that led to this disaster was miscommunication between the Jet Propulsion Laboratory, that's in California, and the space engineers who built the orbiter. The engineers specified the amount of thrust to steer the craft's trajectory in terms of pounds, but JPL, Jet Propulsion Laboratory, assumed the numbers were in newtons. Now you'll know what these units mean later. Thus, it was wrong, and the trajectory was wrong, and this thing crashed and burned. And this cost $125 million because this was screwed up. Now you might say, well, okay, but I'm not going to work in the space industry. You're working in the medical industry, and if you screw up a dose, you can kill a patient. And you might say, well, okay, but I'll never give them too much. If you don't give them enough, they won't get well, and you might kill them that way too. So my point is, units matter more so even than in just raw math. Okay, so units matter, and we'll talk about units a lot. And one student asked me, and again, I'm not, it was a fine question. They said, oh, well, what happens if we don't put units? It's going to be a lot more important here to put units just because you don't want to waste $125 million. Let's go to the next one, Linda, please.
Okay.
Another thing that's true about physics is we're going to be talking about things that are called vectors. So I'm going, and again, I'm reading to you, but this is important. Some physical quantities, such as time, temperature, mass, density, and electric charge, can be described completely by a single number with a unit. Many other quantities, however, have a directional quality and cannot be described by a single number. A familiar example is velocity. To describe the motion of an airplane, we have to say not only how fast is it moving, but also in what direction. So to fly from Chicago to New York, the plane has to head east, not south. Force is another example, and we're going to do a problem about force in just a minute. When we push or pull on a body, we exert a force on it. To describe a force, we need to describe the direction in which it acts as well as the magnitude, or how hard the force pushes or pulls. A tow truck usually pulls a stalled car forward, not sideways. When a physical quantity is described by a single number, it's called a scalar quantity. A vector quantity has both magnitude, how much or how big, and a direction. Okay, so we're going to be dealing with vectors, and we're going to start right now. So let's go to the next problem then, Linda. Here's the problem we're going to do, and if we only do one problem, we'll do this one. I'm prepared to do many more problems, but this is the one we're certainly going to focus on. Okay? And I am not sick, but my voice doesn't sound so good. Sorry about that. Okay, I'm reading again. 3 horizontal ropes are attached to a boulder, and Linda, if you want to point at things, you can, and produces pulls shown in the figure. Okay, so you got one pull that's going out there in the direction of vector A. And you see vector A has that little arrow on top of it, and that means it's a vector. So capital A is a vector, and that means it's there. And it has magnitude, and its magnitude is 100, and that unit is newtons. Now you say, I don't even know what a newton is yet. You don't have to, but it's 100 newtons. The magnitude is 100. And the direction is, it's going off from the origin, 0, 0, and the x-axis is where you start measuring it. It's going off 30 degrees in that direction. That's the direction of A. But then you have another vector that is called B. And B, again, is pointed at the origin, but they're pulling off in a direction of 30 degrees, where Linda's showing you where the 30 degrees is there. So that's 30 degrees, and that magnitude is 8e. And the last vector is going down there. That's actually in the third quadrant, and that is called vector C, and that is 40 newtons, and it's pulling out, in that direction where that angle is 53. Okay, now we're going to do all the things that this problem is asking us to do, but the biggest thing we're going to do is part C, because you have to do all the other things to do part C. Actually, I'm not going to do part D tonight, but anyway. So it up there, and I'm reading it to you. Find the magnitude and direction. And they're saying that should be the counterclockwise angle with the positive x-axis. Okay. Of the resultant pull. That means we're going to be adding these together. Okay. And then we're going to say, okay, so if all that happens, what happens to the boulder? Okay. You might say, well, Jim, you would never ask us a problem like this on a test. Linda, would I?
Oh, yeah.
Absolutely. So, be paying attention here, because I'm not just messing around. Okay. In fact, I rarely mess around. Okay. Let's go then, Linda. We're going to review some things. And Linda, we are going to go back to that thing sometime soon. Let's see. There is some angle stuff here. And Linda, I'm just going to read some of these facts. Now, you guys studied this all in geometry, but we want it to come back. Okay, so interior angles formed when 2 straight lines intersect are equal. And if this were a math class, Linda would tell you we would say equal in measure. This is a physics class now, and so physics is sloppier a little bit, and it just says theta equal phi. Linda, do you want to opine how come theta really isn't equal to phi, but the measure of theta is phi? Go ahead.
Yeah, so angle theta is not angle phi, but they do have the same measure. So that's basically what we're saying.
Okay, and so physics is a little bit, I don't want to say, well, I am going to say sloppier than math. And I picked math to study, but anyway, we have that. So that's an important thing to remember. Another thing to remember comes from this, and Linda, we're going to be going clockwise here, I think.
Okay.
So that's going over there. And in fact, I'm going to pick up the middle. If you add up the interior angles in a triangle, it adds up to 180. Always adds up to 180 in Euclidean geometry. And Linda's studied other kinds of geometry, and I have too, but we're not doing that in this class. So the sum of the angles in this class of a triangle is 180. And Linda, I've changed my mind. Also, 180 is, I'm going down there to the 4 o'clock or wherever that is. Also, something else is 180. If you have a straight line, if you add up the measures of those two angles, they add up to 180. So it's 180 degrees in a straight line too. Okay, now Linda, we're going back up to 1 o'clock or whatever that was. Okay, now if you have a right triangle, what happens up there is there's a 90-degree angle in a right triangle, and there's a little symbol. Linda might point at the symbol, and that makes it perpendicular. The symbol makes it perpendicular. Okay, so you got a 90-degree there, and you got a 90-degree there, and Linda will show you the right triangle there that's on the left-hand side of all that. So that's a right triangle. Now, if you think about that, there's 90 degrees, and that angle is called theta. So if you add those other two angles up, theta and the one that's not named up there, it has to add to, those two have to sum to 90 degrees in order to get 180 in the triangle. Okay, so all that's true. This is true about the parallel lines too, but I'm not going to talk about that right now. Maybe someday we will. This is kind of just-in-time math. Okay, let's go to the next one then, Linda, please. Now, this is one chart that covers all of right triangle trigonometry, because we need right triangle trigonometry to solve this. It's nothing to be afraid of. You stay with this, you ask questions, and Linda and I are teaching you everything you need to know to solve this problem. Okay, now over here, and Linda, this is more or less at the 10 o'clock position. We have a right triangle. Someone left the session. I hope they weren't terrified by trigonometry. You don't have to be afraid of trigonometry. Okay, so what we have here is this is a right triangle, because you can see that there's a 90-degree angle there. Okay, so that is good. And you know some things about the 90-degree angle underneath that, or the right triangle rather, and that's, I think I already said that. But for a right triangle, if you add the measures of those two angles, you get 90 degrees. And you also know something else very important, and that is called the Pythagorean theorem. That says if you take the length of the hypotenuse squared, it's equal to the sum of, this is called the legs squared, so that is a squared plus b squared. Now, and some students just remember that c squared equals a squared plus b squared, but it's important that you remember that c is the hypotenuse, and maybe Linda will go up there, and that's a Greek word. That's the word that people use. So that's the longest side in a right triangle because it's opposite the 90 degree. And so we're going to be using this Pythagorean theorem as we solve things. Okay, so that's good. Okay, so I think we beat that to death about right triangles. Okay, another thing, and Linda, let's go over here to the pi radians equal 180 degrees. When we're doing a problem later, it really is, you have to be careful both in Excel and with your calculators. Almost all the time in this class, we're going to be talking about degrees. Now in math classes and in calculus, you use radians, but this is not a calculus class. Most of the time it's degrees, but you can screw up if you don't have your calculator set right. And that looks really blurry to me, but that's supposed to say be careful with your calculators settings and with XL. And we'll be careful with that. Okay. Now, Linda, let's go down to the bottom where I say there are two great problems. Just like in normal statistics, I said normal things, I said there were two great problems. There are two great problems here too in right triangle trigonometry. Given the sides, find the angle. And the other one is called, given the angles, find the sides. So what we're going to be doing here is, and now we're going over here in terms of that right triangle. Now, Linda, we're doing the only part we haven't talked about over here. We define some functions, and this is like f of x, and that's called the sine of theta. And the sine of theta is the opposite over the hypotenuse, or in the picture that Linda has right above that, it's a over c. That's the ratio. And the only reason this works is because the triangles are similar, but don't worry about that. This is just the tool you need to do the problem. That is a function. Okay, we also have a thing called the cosine there, and the cosine is the adjacent side over the hypotenuse. It's the ratio of those two. It is b over c. And Linda's showing you in the picture, and that's what's there. And there is a tangent theta. That's equal to the opposite over the adjacent, and that's a over b. And if you think about that for a while, that sine theta over cosine theta has to be the tangent theta. Okay, so anyway, those are the definitions of the trig functions. Now we're going to use these whenever we know the angle. That's going to help us find the sides. And then there's a thing called the inverse trig functions. Yeah, there. And Linda is amazed that I got all right trigonometry on one chart, but I did. Okay, so inverse trig functions, and that's by S inverse of x, or it could be arc sine of x, and we'll talk about how you do this with XL and everything else. But this gives you a value equal to the angle that has the value x for the trig function. Okay, and we're going to look at that and everything else, but you see that answers the other question. If you know the sides, you can find the angle by using that. So we're going to be solving our problem doing this. Okay, and we are going to go back to that problem in a bit, Linda. Okay, so Linda, let's advance the slide and see what else I have here. Okay, now this is our approach. So Linda, at the very top of the slide, and she's pointing up there, thank you for doing that. That says vector A is equal to A sub x, vector A sub x, plus vector A sub y. So you see vector A is the vector sum of A, x, and A, y. We're solving these vector problems by components. When I teach a trigonometry class, I teach a lot more than this. I'm teaching you just what you need to know. You will know how to do this if you pay attention and dig in. It's going to be fine. And you can always ask questions. And the way we're going to do it is we're going to, and Linda, this is showing the component vectors down there. So there's the vector A. So you see A going off there at an angle theta. And what we do is we drop the perpendicular to the x-axis. So vector A goes out there, and the other x-axis, there we go. Okay, the x-axis. And by the way, you could get fancy and you could drop those perpendiculars all kinds of ways. With 1120 students, I usually say, always drop it to the x-axis, just so you don't get confused. Now, that's not written here, but you might want to make that little note somewhere, because that's what I'm going to do when I'm working the problem. That's what Linda will do when she's working a problem. Again, she knows how to do it differently, and I do too, but that's what we're going to do today. So you always drop it to there, but the y component is the other one. It's the y component, and Linda will show you that the y component, that's over there, but Linda, show them that the y component, AY, is also in that same triangle with AX.
Right there.
Yeah. Good. Okay, excellent. Yeah, I think we did. Oh, well, and let's go down here. Well, all right, and what we're going to find is that AY is equal to A times sine theta, and AX is A cosine theta. So we're going to be doing all of this for that problem that we're doing. And you might say, oh my God, do I have to memorize this? No, I give you grace notes that have this kind of stuff in it. but you should know how to use it, and you definitely need to know how to use your calculator. Okay, Linda, can we go back to the problem, please? And I know we're going backwards now. Okay, now there are three vectors, A vector, B vector, and C vector. We're going to operate on each one of those. And Linda, I'm sort of changing my mind. Are you willing to, and I'll remember this is 100 at 30, are you willing to go to I really should do this. So is this the chalkboard? No.
So if you go under share content, then it's the first option, which I can do that. But you can write on this.
I can write on this? Yeah. Okay. All right, I'll try that.
Yeah, so just click the little pencil
Linda,
icon on the top left.
Linda, you were sort of recording these numbers, and what's going to happen in just a bit, Linda, I'm going to ask you to work this twice. The first way I'm going to ask you to work it with the numbers is use the calculator that's here on the machine, because I let the students use that, and they should all do that. But okay, so I can draw here, so I'm just drawing here with this, but I'm working on A. So what I'm doing then is, oh God, this is pathetic. Okay. This is not a good drawing, but it is what it is. Okay, so vector A goes out like this. And that is 100. We always drop our perpendicular to the x-axis. So I drop it down here, and that's perpendicular, and it is this. So that means that this is AX, and this is AY. Now, no one's asking me a question, but what the hell? I'm going to pause and see. Are you with me or not? Just don't do a poll. Do you have questions or not? So far. Oh, we are doing a poll. That's all right. Okay. Well, I'm going to say if you do have questions, I don't know what I really said here, but if you do have questions, please ask them, because there's no way that we're going to know what your questions are unless they're asked. Okay, and maybe people are reluctant to ask questions, but again, you should, I don't know, maybe, I don't know. Anyway, that's okay. We don't know who that is, and you're welcome to ask questions. But okay, so we're there. That's good. Linda, we'll lose the poll. Great. And now we're back here on this. And now what I'm going to do is I'm going to talk about this angle. Now this angle was 30 degrees. So now we're going to talk about that, and I'm going to go up here. Actually, Linda, this is way back. Good. This was a good idea you had. This is way better than moving back and forth to something. Okay, now I'm going to say something that, okay, and by the way, I'm doing this. This seems like I'm pulling this out of the air. This is just formulas, but I've taught a lot of trig and stuff like that. In fact, when I teach the, I don't want to say a real class, but when I teach in the classroom, I actually tell a story about my uncle. I'm not telling that because students really don't like my stories. That's actually one of my favorite stories. Sine of 30 degrees then is going to be equal to the opposite over the hypotenuse. So this is AY over 100. Now in a bit, okay, and that means that if I solve for AY, I can multiply both sides by 100. So AY is equal to sine 30. And in class 2, I show off because I actually know what the sine 30 is. Linda does too, but we're going to use the calculator for that. That's sine 30, and I know that's sloppy. Similarly, x is going to be equal to 100 times the cosine of theta. And of course, those are vectors again. I wonder if I practice this, if I get any better. Probably not. Maybe a little bit. Okay, so that's what we're going to do. Now, Linda, so we have AX is equal to 100 cosine of, and that's supposed to be 30 degrees because we knew what theta was. 30 degrees, and that's sine 30. Okay, so Linda is going to compute that on, she's going to do it on her calculator to start with, and then she's going to record those values in Excel. Linda, am I making sense to you?
Yeah, you're good.
Okay. All right. So, Linda, you have the ball, and talk about how you're going to do this in a. And I don't know if you want to go into Excel first and write down those formulas, and then come back and do the calculator to get the numbers or something. That's fine.
I have a question.
Okay, Simone. Yes.
So with the I think you put the cost. Is that one 32? Is sin 30 and cost 30?
It is 30 also. Yes.
Okay.
And I'm not good at writing on this slide, but anyway, we have that. Okay. And Simone, thank you for asking questions. And maybe I don't thank other people, but everybody, I appreciate questions. That's good. That's what you all should be doing. Linda, you have a ball. Go ahead.
I have a question.
Okay. I don't know who that is, but go ahead.
Sydney.
Yeah.
So where does the cosine come from?
Because the cosine is the opposite over the hypotenuse.
Cosine is adjacent over hypotenuse.
Oh, that's what I meant to say. I was pointing at the adjacent. I'm sorry. It's the adjacent over hypotenuse. I did, the things I wrote were right.
Okay, thank you.
Okay, so Linda has the ball now. So we'll go ahead and I'm going to check that text to see if there was a problem.
Okay, so I am sharing my screen. I've got these formulas in Excel. And can everybody see this okay?
Yep.
Okay. So what I have right now is just the formulas written out. And then what I'm going to do is just type them into my calculator on my computer. So first thing is I need a scientific calculator. And then I'm going to expand this a little bit so I'll get more options. Let's see, there's my trigonometry stuff. So I'm taking the cosine of 30 degrees first. So I need to type in my degrees. And you can tell it's in degrees because of the DEG right here. And I'm taking the cosine. So that is my cosine of 30 degrees. And then I'm multiplying that by 100. So I get 86.6. And I'm going to put that right here. Okay? Any questions on that?
Yeah, can you do that again? I'm sorry, I missed it.
Yeah, absolutely. So if I clear everything out, then 30 degrees is my angle, right? So I'm typing in 30. Then I went under trigonometry. I hit cosine, because that is the trig function that I'm taking. And then I multiply that value by 100.
Someone asked a question, and I want to respond to that. That calculator is available to you on tests and things like that. And so that's one of the reasons I want Linda to do it. Now, we will talk about Excel, and I'm not 100% sure, but I would bet all the money in my wallet right now that Excel is a little fancier beast, and it's going to want things in radians. Now, maybe Linda knows a way around that, and you could change things, but I think Excel wants things in radians, and that's a little bit more complicated. And that's why whoever asked that question, it was a good question. All questions are good. I'm not going to say that every time. All questions are good. But that's the reason I was asking Linda to focus on this, because I want to stay away from, as much as we can, the radians and degrees things. I do that when I teach calculus because I'm supposed to do it when I teach calculus. I don't need to do it here, so I'm not doing it. So, you know, this is a good way to do it. And I am going to ask Linda to maybe show you something about that. But I think I'm right, Linda. And maybe Linda has a clever way to do it with degrees, and we'll see. Okay, so that is good. Unless, oh wait, we still need to do AY, don't we, Linda? I'm sorry, I will shut up.
Yeah, somebody asked me to repeat it. So then
Okay.
I'm clearing out all this, and then just like before, I'm doing 30 degrees. And then under trigonometry, then I'm taking the sine of 30, and then once again, I'm multiplying that by 100. So now I get 50.
So you see what Linda has done so far is she has found those components, AX and AY. Now, Linda, can we go back, and we're going to save that. I mean, we'll come back to this. We're going to go back and do that for another thing. And so can I erase what I did on that slide?
Oh, it's already erased.
Oh, okay. So that's actually good hygiene, I guess. Here we go. Now we're going to do B, okay? Now, it is important that you realize that the geometry matters. You see B's being pulled out this way. But I'm going to sketch B roughly over here. Oops, I need to grab the pencil, I guess. Hey, if I hold Shift, Linda, does it make a straight line? No, that would be too much.
There is a way to do it under shapes, but I found it to be more trouble than it's worth.
I'll take your advice on that. Okay, so this is B going out this way. Now, everybody, this angle here is 30, but I told you to drop the perpendicular to the x-axis. Always to the x-axis. Again, you might say, well, can't you do it differently? Yes, I can, and Linda can, but I'm telling you drop it to the x-axis so no one gets confused. This is 80 going this direction. So that is 80 newtons going that direction. But now I have to be a little bit clever because it showed me the 30-degree angle right here. And you see this, the x and y axes are perpendicular one with another. That means that they add up to 90 degrees. So if this guy up here is 30, this guy down here is
60.
And this guy up here is 30. Now, we don't really care about that, but, well, I don't know, maybe you do, but that is up there. So that's good. I mean, we know some things. So that's here. And you see this guy was called B. So that's the vector B going off that way, and the magnitude is 80, and the direction is now 60 degrees with the x-axis. So that's good, I guess. But then this is B, Y, because that's parallel to the y-axis, and this is B, X. But, boys and girls, it is very important that you realize that while you see with AX was positive and AY was positive. Over here, there's 0. So BX is in the negative direction and BY is in the positive direction. These are vectors, so the direction makes a difference. So positive is not the same thing as negative. So this is going to be a negative number, and that's going to be a positive number. Now, what I'm going to do is, and this is the same logic that I did before, and I think I'm going to maybe fast forward this a little bit, but you see, just as we did before, I can say that B, Y, that's B sub Y, Do I want to erase that? Is this the eraser? Oh, shit. Sorry, I didn't say that. Okay. All right. So anyway, so B is going up there. Maybe I'll draw a better picture this time. I have a way better vocabulary than that, guys. I'm really sorry. That was inadvertent. Okay, so B is going up this way. And we got BX and BY. We always drop the perpendicular this way. The BX was negative, we said. And BY. That was what you were warning me about, wasn't it, Linda?
It was.
Now I know. You see, folks, I made a mistake, and I'll remember that now. So that's good. And you see, I didn't remember it when Linda warned me about that earlier. Okay, so we got this, and this angle we declared was 60 from the analysis that we did, and I said this has to be negative. Okay, so now I'm jumping to the chase then. So B sub x is going to be equal to the negative of, and this is going to be 100.
80.
It's 80. Oh, darn. Okay, so here we go. 80. But it is,
Beautiful.
and thank you, Linda, negative 80. And then that is going to be the, because that's the hypotenuse, that was 80 up here. So that is negative 80 times, and the minus is really coming from down here, but you know, that's fine. And let's see, so BX, and this is going to be the cosine of 60 degrees. And similar to what we did, I'm going to go over here and write it. BY is going to be, this one's going to be positive, and this is going to be 80. And this is going to be the sine of 60. Okay, so that is really...
I had a question.
Okay. Now I think, and I will be with your question in just a minute. Linda, after I field whatever questions are out there, you know, I'm going to be turning this back to you, you know, just to go and do some things. Someone had a question. I don't know who it was, but that's okay.
It's
Shout
Sydney.
it out. Yeah, Sydney, go ahead.
Can you just explain why BX would be the cosine and why BY is the
Sure.
sine?
Of course I will. Okay, so I'm doing it up here. Now, it is important, Sydney, that you realize that I've drawn that right triangle, yes? So the hypotenuse is this one, 80. This is the side that's opposite 60 degrees. This is the side that's adjacent to 60 degrees. So our equations tell us that the cosine of 60 degrees is equal to, let's see, BY all divided by 80, because it's going to be the length of the adjacent divided by the length of the hypotenuse. And then what I did is I multiplied both sides by, that's not supposed to be B. I was talking about BX here, actually. That's the cosine. I think I was saying X and writing Y or something. But okay, so this is the cosine. So the cosine of this is going to be BX, the adjacent, over 80. So when I multiply both sides by 80, I will get BX is, here's the cosine of 60, there's the 80, and it's minus because this is going in the negative X direction. Sydney, are you okay with that discussion?
Yes, thank you.
Good. Now, this one's going to be almost the same thing. You see, here I'm going to say, I'm not going to write all this, but BY divided by 80 is the sine of 60, and that BY is going in the positive Y direction, so that is positive. So that is 80 times the sine of 60 degrees. And Sydney, you're okay with that then?
Yes, thank you.
Okay, excellent. Linda, I'm giving you the ball. Go ahead.
Okay.
I got a question.
Okay, was that Simone? I don't know.
Yes, it's
Yeah.
me. So
Okay.
the 60 came from where?
The 60 came from this part of the triangle. Now, way back when, you see in the picture originally, this is 30 degrees, but from the y-axis to the negative x-axis is 90 degrees. So even though this is 30, if you take away 30 from 90, you get 60. So that's why I'm dealing with the 60. And the reason I'm using this angle is because I've told students it's better for them always to drop the perpendicular to the x-axis, just so there's no confusion.
Gotcha. Thank you.
Excellent. Okay. Now, Linda, I think you do again have the ball.
Okay. So I've already got this typed out on Excel. And you'll see that I kind of amended it to include the signs for each of these, just because if I try to type in a negative in front, then it's giving me an error. So I'll do it the long way. So for the first thing, what I'm doing is taking the cosine of 60. So once again, I'm typing in my angle. And then under trigonometry, pick cosine, and I get 0.5. Now I'm multiplying that by 80. So that gives me 40, but my little note here, because it's going in the negative x direction, then that's a negative 40. Everyone okay with that?
Yes.
Okay. So then next, to finish this up, then I'll clear all this out again. So I'm typing in 60 once again. Now I'm taking the sine of it, and once again multiplying by 80, since that was my hypotenuse. And I get 69.3 approximately. So because B is still going up, then that's still a positive 69.3. Any questions on what I just did?
No.
Apparently a brilliant exposition. That's great. So let's move away from brilliance and we'll go back and look at the slide again. And now we're doing C.
Okay.
Okay. So I'm going to look at C. Now this is C down here. And so I will draw C here. No, I have to get the pencil first. Okay. And C is going down like this. Now we know that the hypotenuse is 40. And we always drop our perpendicular to the x-axis. So this is what I'm going to do. That's the perpendicular. That's a triangle. Okay. And here's the 90-degree angle because the x is perpendicular to the y. So that's the 90-degree angle. And lo and behold, that's the angle that I want. This is 53. I'm going to pause and see. Everybody see where that triangle kind of came from?
Yes.
Okay, good. Thank you, Josh, I think. But whoever said that, thank you. Okay, so now what we're going to do is, now this thing is called C, but now I want everybody to think about this. And if we were in class, we do polling and stuff like that. We're not going to do that tonight. But you see, for C, the x component is going out this way. It is negative, and the y is going down. It is also negative. So much as I did before then, and this is called C, this vector here. So much as we did before then, CX, that's the component of C in the x direction, is equal to, and I got to be careful here to do this right because Linda will think less of me if I don't pay attention. Okay, and Linda's also thinking, oh, you should have put the negative there, but I did just then. So that is minus 40. And you see this, I said CX, so you see CX is up here. So that is the adjacent over the hypotenuse, which is known as the cosine. So this is the cosine of 53. And I would amaze you if you were in class by telling you what the cosine of 53 is. Okay, someone asked a question, why is it minus 40? Well, it's not a minus 40, but I'm going to be multiplying by cx, so cx is in the negative direction because the x component's going this way and the y component's going down. So that means that the answer has to be negative. And so it really wasn't a negative 40. I mean, the negative, okay, she got it, good. Okay, I was doing that. So there's a thing. And then over here, we have a cy. And cy is going to be, Linda's doing quadrant things. That's good. We both can write at the same time. How cool is that? Okay, so we have this. And remember, this was negative again. So it is negative 40. And this is going to be in that triangle. There's the 53. So that's the opposite over hypotenuse. And so this is going to be the sine of 53. And if we were in the classroom, I would amaze you because I actually know what the sine and cosine are of 53 as well. So, and Sydney, I'll call on you right after I write 53 degrees. I'm calling on you, Sydney. Go ahead. Yeah, Sydney.
Now, what did you do to determine which side was CX and which side was CY? Like, how did you make that determination?
This is the x-axis here. So it's the side running along the x-axis is going to be, and there's my angle, 53, and that came from the problem. So this is going to be going this way, so it's along the x-axis. That makes it x. And if you go back and look at some of those earlier charts, I kind of said that, although I didn't probably do a good job explaining it. And CY is the triangle going along the y direction, parallel to the y-axis. Okay.
Okay.
Linda, I think I've done enough damage here. Go ahead. Well, wait. Linda's going to do this, but you see, we said we wanted to find the resultant of this. So Linda's going to finish this, but then you see when we said we wanted to find the resultant up here, that means we have to add these together. So we're going to add our x's together and our y's together, and Linda will probably do that too, and then we'll return here to think about the last part of this. So Linda, please, you have the ball again.
Okay. So I'm going back to Excel, and once again, I'm going to type these into my calculator. So first, I'm getting the cosine of 53 degrees, so I type in 53. Then under trigonometry, I'm picking cosine. And then I'm multiplying that by 40. But because this is in the, hold on, there we go. Because this is in the third quadrant, then this is actually going to be negative. So that is negative 24, and I think this was actually supposed to be 53 and some decimal because that is a Pythagorean triangle.
I got a question.
Yeah.
If you put the negative sign in a calculator instead of adding it at the end, will it change the answer?
So not in the calculator. The only reason why I didn't include it here is just because Excel gives me an error if I try to do something weird with that. So I just didn't write it with the actual formula here.
Okay, gotcha.
But you can just as easily undo this and let's see, 53, we'll do sine this time, and then multiply that by negative 40. And that should have been negative, but I guess it didn't get that. There we go. So negative 32. So then for part B, find the components of the resultant. And what I'm doing is adding my x components and my y components. So I'll call this our x and our y. So to get this, then I'm doing sum, and then I'm just clicking on the numbers for that one. And close my parenthesis, and there we go. So then I'm going to do the same thing for my y values. Close my parenthesis, press enter. So this would be my resultant.
Okay, Linda, I'm going to probably, I don't know if I probably won't remember those, so in a bit I'm going to ask you to, you know, tell me those numbers if I don't remember them. But anyway, we'll see.
I have a
Okay,
question.
now we have the Rx and the Ry, but
have
you
a
see the
question.
problem asks you to find the resultant, and so we wanted to have the we want to have not Rx, Ry, we want to have R, and we also want to know the angle. Simone has a question. Go ahead, please.
So the answers are positive, they're not negative?
Yeah, so when we added the numbers together, then we ended up with a positive number for each of them. So this just means that your resultant would end up in the first quadrant.
Oh, okay.
Okay, let's go back to the, oh wait, Simone, you good, or you still have a question?
I'm good, thanks.
Okay, I'm lowering your hand then. Okay, that's good. Okay, so now, Linda's changing this back, and we're going to go and talk about this resultant then. Okay, now you see, we know the X and Y coordinates, or components rather, of this vector, and as Linda suggested, it is going to be in the first quadrant. And I think this was 22.6.
Yeah.
In the X direction, and in the Y, it was 87.3, I think.
You got it.
When I was young, I was really good at numbers. Still not bad, I guess. In fact, Linda, the 5337 right triangle is damn close to a 345. Not exact, but damn close.
Yeah,
And
I just rounded it.
And in physics, we always rounded it off that way. That's how physics was different. Now, by the way, if this is 22, then you see this 87 is going to be like 4 times that. So it's going to be like way the hell up here. And so the R we're seeking is this one right there. But here's your 90-degree angle. So that means that the R that we have up here is going up here. Now, if you look at this and you say, wow, that's much bigger than this, so that's going to be, you know, getting closer and closer to 90 degrees, and we'll figure out what it is. But this is an angle that we don't know what it is yet, okay? But here we go. We know that if I take the magnitude of the hypotenuse, R squared is going to be equal to 22.6 whole squared plus, can you write on using this as stylus on this thing? Oh, no, not on my machine, that's right. Okay, so I have that, and then this is 87.3 whole squared. And that means that R, and I can't erase that, pretend that's not there, is the square root of that business. That's the length of R. But you see, we have to specify not only the length of R, but the direction of R. But that's going to be the length of R, and Linda will do this calculation in a minute using Excel. But you see, now we have to know an angle. And remember I said that was the second great problem. One great problem was, if you know the sides, or if you know the angles, find a side. But now we're saying, if I know the sides, can I find the angle? So what's going to happen here is that theta is going to be equal to, and let's see, I think Sydney would ask me about this, so I'm going to go ahead and write it up here. The tangent of theta, now there's the theta, so the tangent of theta is equal to 87.3 divided by 22.6, because it's here's theta, it's the opposite over the adjacent. So that means that theta is equal to, I'm going to just say inverse tangent because that's what's on Linda's calculator. The inverse tangent of that number, So that is 87.3 divided by, this does slow me down writing this way. Maybe that's a good thing, I don't know. Okay, and you got to make sure when you're using the inverse trig functions that you're set in degrees also, or else you'll get a wrong answer. Okay, so Linda, I think you're more than ready to take this over, aren't you?
Yeah.
Go for it.
Okay. So let's start by getting squared. Then to get that, we're doing equals. I'm taking my x component, so in this case, the 22.6, and squaring it. And I'm adding to that my y component and squaring that. So then to find r, or the magnitude, then I'm taking the square root. So equals whatever this number is, and I'm raising that to the 0.5 power. We get about 90.2. Everyone cool with that?
I don't hear any chatter, so okay.
Okay.
Yes.
So then we were told by Professor Bradley that the tangent of theta is equal to, let's see, that was 87.3 divided by 22.6, right? So then in my calculator, then I'm going to do 87.3 and divide that by the 22.6. And then I'm going under trigonometry, and let's see, I need the inverse. I'm not sure where that is though.
Yeah. Yeah. I am teaching, but Linda's there.
Maybe under second. There we go. So 75.5 basically. So then in your notes, then I'm putting the tangent inverse
It is a
of
scientific.
87.3 divided by 22.6. And when we computed that, we got, let's see, 75.5. So that would be a 75.5 degree angle.
Hey, Linda.
Yeah.
I know I'm interrupting, but I'm dealing with some students who are, testing right now. Can you show the calculator? And I think there's a caret there for doing a power function. Can you throw up the scientific calculator?
Yeah.
How's this for multiprocessing? Okay, so the caret's there somewhere, isn't it?
Yeah, it's an X to the Y button.
Here's what you need to do, Jane. It's the X, the Y button, and enter two things. And again, I told them to practice that calculator, but they can get that using the X to the Y button. Yeah, X, but it shows the Y as an exponent, okay?
So like that.
Yeah. Okay, all right, and just tell them they can do that. And Jane, I did tell them to practice the calculator too. So anyway, okay. 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 All right, bye-bye. Okay, thank you, Linda. That's good. Okay, let's see. And I'm sorry, did you finish the problem, Linda, or not?
Yep, just finished.
Okay, so, and by the way, that's degrees. So you see this vector is going up. So if you did all those vectors and add them together using this process, that's the direction, and that's how long it was. And that's a good example of a physics problem. Now, Linda, I'm going to ask you, and let's just, this goes back to a question that one of the students, actually I know who it was, and it was, all the questions are good. Let's look at the sine and cosine and tangent. Let's just look at one of them. Let's just look at the sine. But I think you have to have radians using Excel. So click on that FX up there or something, and let's find
Okay.
or we're just looking for it there. Okay, so let's look at sine. And in fact, Linda, let's test this, okay? So let's do sine of pi over 6. So just, you could type, well, okay, she's doing 30, that's fine, go ahead.
Yeah, so I think you have to do radians.
Oh, and you know what it says there? This is the angle in radians for which that is. So whoever was answering that question, actually for everybody, not just for them, you want to be careful about this. Now, I will tell you, and I just know from experience that it was like this. You want to be careful about this because you have to change the degrees to radians. That's why I was telling Linda pi over 6 to test there, because I changed that in my head. But anyway, so you're better off with the calculator doing this problem, I think, Linda, yes?
Yes.
Good. Okay, that's great. Okay, so we checked that out. And now I am watching the time for you because I always do that free of charge. And we do have about 10 more minutes, and we're going to use those 10 minutes. So Linda, let's go back to the slides, please.
Okay, so I did mess around with that a little bit more, and it is possible to get the same thing using Excel, but you have to work a lot harder for it. So this is the actual equation you would have to plug in to get the same thing.
And I did give you that equation because I said pi radians was equal to 180 degrees. And that's what Linda actually did there. She solved for theta, or she solved for...
Yeah, they actually give you this in Excel. So if you look at the sine function, then it actually tells you degrees times pi divided by 180 equals radians.
Okay, so I mean, you can use Excel for that if you want, but make sure that you realize you have to do that, okay? All right, so that is good. Let's go back to the slides then, Linda, please.
Okay.
And Linda, we might do a little bit of a poll, of people. Okay, now, all right, and I think this slide was like at the beginning or something, so let's just go through a few slides and figure out where we are. Keep going, please. Oh wait, yes, it is in chapter 1 of the physics book, and there is a chapter 0 in the physics book too. Now, chapter 0 is called exponents. That problem that Linda showed you, I think that was 45, but whatever it was, that was problem 1 from problem 45 from chapter 1. Okay. Now there is a chapter 0 that says math review, and I really do think about you guys, and so there is a math review about exponents there. It talks about cubes. I'm not going to take you through all that. Linda, can you point, or I don't know if I can point or not. Can I point too?
Yeah. If you
Okay,
click on the little finger pointer button next to the pencil, then that'll give you the pointer.
Okay, so I will finger point then. Okay. This is just one thing, and Linda's done this before, but an exponent can also be a fraction. So if you say x to the 1/4, that is a fourth root. And if the exponent is 1/2, it is a square root, and 1/3 is a cube root, and yada, yada, yada. And by the way, we just learned that raising those things to a power, you have to use an x to the y key, and you might want to practice that because it sounded like some of your mates in the business calculus didn't practice that, and they were having a revolt because they didn't know how to do that. Anyway, okay, so that is good. So you should know about exponents, and because those will come up. Linda, let's go to the next slide, please. And here's some examples. There's rules of exponents as well. And here's the rules of exponents. Now, you studied these in many of your math classes, things like that, but you might have to do these. So here they are, okay? And oh, here is, well, let's see. And it does matter because we do have negative numbers. If you raise a negative number to a even exponent, it's going to be positive. If you have a negative exponent, you raise it to an odd power, it's going to be negative. Okay, so those are things about exponents. Just reminding you, they're there for you to read, but that's not what we're going to focus on. We're going to try to do physics problems. So let's go to the next one then. Here's some problems you can do with exponents, and I can write on this, can't I? Yes?
You can.
All right, so I'm going to solve one of these problems for you, okay? And the problem that I'm going to solve is, don't really know if this is the best problem to solve, but I'm going to do it anyway, number 4. Okay. Now, as long as you know what you're doing, you can do things in different orders and things like that. And I know what I'm doing, but I also am enough of a teacher that I want to give you guys good advice if you don't know what you're doing as well as I know what I'm doing. So it makes sense to do the order of operations. So we're going to do things that are inside the parentheses first. Okay, so let's look at that. I have an x to the minus 4 over x squared. Now we learned that you're going to subtract exponents there. So that is going to be x to the minus 6, but that really is going to be an x to the 6th in the denominator. So that's an x to 6, and at the end of the day, that's going to be in the denominator. And here I have y to the minus 4 and over y to the minus 2. So that is going to be minus 4 minus a minus 2. And minus a minus 2 is a plus 2, so that is y squared. So I get y squared, and that was y to the minus 2, but that's really y squared in the denominator. And so you see now I've simplified this, except really there has to be a 1 up there. So this is minus 1 over. So I did what was inside, simplifying that first, and that is to the 5th power. And now what I'm going to do is, now this is an odd number. So my answer is going to have a negative on it. And then I'm going to have 1 to the 5 over x to the 6th whole to the 5th. And I could have done that differently, but that's the way I said I was going to do it. And this is y squared, and that is whole to the 5th. That was y squared whole to the 5th. So this is going to be, the final answer, I'll put it over here, is going to be minus 1 over, and that is x to the 30th. And that is y to the 10th. Questions on this? Good. Okay, Linda, let's go to the next slide, please. All right, now you watched a Powers of 10 video. I hope you did. If you didn't, go look at it because it's kind of an iconic video. It's actually very well done. I like it a lot. In fact, that may be the best 10 minutes you'll spend. I think it's 9 minutes and change. That's the best 10 minutes you're going to spend in this course watching that video. But anyway, I'm going to read a little bit. I do know what time it is, so don't worry about that I've lost track of what's going on. I actually always know what's going on. Okay, so in physics, we frequently encounter very large and very small numbers. Okay, and it is, yes, I love that video. And it's important to use the proper number of significant digits. But here's the thing, even in ultrasound, you're going to use very large and very small numbers. The very small numbers are going to be the distances that you do. And that video showed you going into the, like DNA and stuff like that. And then also there's very big numbers. You guys say, yeah, but ultrasound doesn't go to Mars or something like that. No, it doesn't. But the frequency you have is in megahertz. So that's a big power of 10. And so you are in ultrasound doing those. And actually those are there. So we're going to be talking more about this. So both of these issues are addressed if we use what's called scientific notation. And what we're going to do in scientific notation, I'll grab my pencil. I'm getting really better at this, I think. I'll grab my pencil. No, it won't let me have the pencil. Why didn't it give me the pencil? Oh, well, it doesn't want me to have the pencil. But anyway, we say numbers like 6.3 times 10 to the 4th, and that ends up being 63,000. You see, this is a lot easier to write than that. And so on and so forth. So we use this when there's a bunch of zeros involved. Linda, let's just be a poll, okay? You guys excited?
Hold on.
Are you excited? Way to go. Okay. Time is precious. Each day must count. Do the math. It will make you strong. We're done for tonight. I'm going to have office hours in about 15 minutes if anybody wants to come. Take care.
Thank you.
Everybody.
Have a great evening.
Have a good weekend. Yeah.
Professor Bradley,
Yeah. What's up?
it's